Okay, in this lesson we are going to talk about adding integers again, but this time we're going to be talking about using chips instead of number lines. So in the last lesson we talked about using number lines, and in this lesson we're going to talk about using chips. So just remember a little bit about an integer. An integer is a positive number, a negative number, or zero. It is not a fraction or a decimal. So the first vocabulary term we need to know when we're adding integers using chips is this idea of a zero pair. I'm going to go grab my pen over here. A zero pair. And a zero pair is a positive chip and a negative chip, just like that you see here circled. Now, the neat thing about a zero pair is that a positive chip and a negative chip, they actually cancel each other out. Let me show you how. If you remember from the last lesson, we talked about additive inverses. Basically, you have a positive number and you have the exact same negative number, and when you add them together, the sum is zero. For example, if I had -4 and I added a +4 to it, it's going to give me a 0 because -4 and 4 are additive inverses. So when we look at our chips, if we have a -1 chip or negative chip and we have a positive chip, that's going to give us 0. So the chips are basically additive inverses. So let's see how this applies below. It says, how many zero pairs can you create? The question says -5 plus 3. Okay, well, I'm going to use red for my negative and yellow for my positive, and I'm actually going to draw these out to show you. -5. Okay, well, -5 chips look something like this. There you go. I have 5 negative chips, and that's represented right here. Now I'm going to go ahead and grab my yellow pen. See if I can maybe grab a darker yellow so we can see it. It's kind of orangey. Okay, so I have +3 chips. I have 3 positive chips. So I'm going to go ahead and represent that by 3 positives. Okay. Now, I lined them up like this really nicely because you're going to see that when we line them up very nicely, it's very easy to see our order or our zero pairs. So I'm going to go ahead and I'm going to change my pen and I'm going to circle all of the zero pairs. You're going to notice that I have 1 zero pair, and then I have another zero pair, and then finally I have my third zero pair. So in this problem, we have 3 zero pairs. Now, that's what the question is asking. It's asking us how many zero pairs can we create. But I'm going to take this a little above and beyond, and let's go ahead and see if we can actually answer the question. -5 plus 3. Well, if I have -5 chips and I'm going to add +3, well, the way that you get the answer to this is you actually look at what's left over. So I'm going to change my pen color real quick to blue. Look at what's left over. Notice how I have a negative and a negative. I have 2 negative chips. Therefore, my answer to this expression is -2. Okay, let's try another one. 6 plus -3. All right, I'm going to start with my positive, which is my yellow. So I'm going to go ahead and draw myself 6 positive chips. Okay, there they are. So that represents my +6. Now, I'm going to add -3. So adding a -3, anytime that you see a plus and a minus next to each other like you do here, what that means is basically you're going to take those two operations and you're going to make it a subtraction all the time. Okay, but for right now, we're just focusing on the chips. We're going to get more to the operations when we get to our subtraction portion of the unit. But for right now, let's go ahead and just look and focus on the -3. Let's go ahead and draw ourselves -3 chips. There they are. Now, I'm going to go ahead and create my zero pair. And I have 1 zero pair. I have another zero pair, and I have another zero pair. Those 3 zero pairs are additive inverses of each other. So essentially, they cancel each other out. If you ask yourself, okay, well, what am I left over with? Let's see what we're left over with. We're left with 1, 2, 3 positive chips. So therefore, my answer is going to be positive 3. So 6 plus negative 3 is going to equal 3. All right, let's try a few more. Now, I know that the directions here say add the integers using chips and a number line, but for right now, I just want to focus on the chips. Since we focused on the number line yesterday, or in the last lesson, we're going to focus on just chips. So let's go ahead and let's look at the first one. I'm going to first grab my red because it looks like I have a negative 3 to represent. So I'm going to say 1, 2, and 3. There are my negative chips. I'm going to go and add, I'm going to go and grab my yellow now, and I'm going to do positive 7. There they are. All right, let's see how many 0 pairs we can create. There's 1, there's 2, and there's 3. Now, there's not always 3 0 pairs. It's just a coincidence that the last 3 problems had 3 0 pairs. But in our case, this problem did have 3 0 pairs. And if we look at the answer to this one, how many are left over? Well, we have 1, 2, 3, 4 positive chips left over. I'll show you where those are. Here they are. 1, 2, 3, and 4. All of those right there, that is going to be your answer. So negative 3 plus 7 is going to give you a positive 4. All right, let's look at the next one. Positive 4. Okay, I'm going to start with my yellow. I'm going to represent positive 4 chips. So here they are. And then I'm going to go ahead and I'm going to notice that I also have a negative 8 here. So I'm going to go ahead and represent negative 8 chips. Here's my 4. And then I'm going to do another 4 to make 8. And then I'm going to go ahead and I'm going to make my 0 pairs. Sorry if it's a little sloppy as I circle these 0 pairs, but it looks like I have 4 0 pairs in this problem. So what's left over? Notice what's left over after I create those 0 pairs. 4 plus negative 8, well, I'm left with negative 4. And that's my final answer. Okay, let's do another one. Notice how this time I have like numbers. I have 2 positive numbers. So let's see what that's going to look like. I'm going to grab my positive yellow, and I'm going to go ahead and draw 3 positive chips. And now I have another positive number, so I actually don't have to change colors. I'm just going to go ahead and I'm going to add 2 more positives. Well, 3 positives and 2 positives, I can't create any 0 pairs. So there are actually 0 0 pairs in this problem. And when I add them, you know, what's left over after I circle all the 0 pairs? Well, I have a positive 5 left over. Same thing over here. Now I'm working with negatives, so I'm going to grab my red. I have 2 negative chips, and then I'm adding another 5 negative chips. Can I create any 0 pair from all these negative chips? No. So I have 0 pairs to create. And when I add these, how many are left over? Well, I have 1, 2, 3, 4, 5, 6, 7. I have negative 7 chips. Okay, so one thing that you notice from this slide is that when you have opposite numbers, like if you have a negative and a positive, or a positive and a negative, you're going to have to create some 0 pairs. But when you have numbers that are the same, like a positive positive or a negative and a negative, you don't create any 0 pairs. Okay, now let's take a look and see what we can do here. In this problem, we're going to use the number line to represent the addition problem using chips. So, first of all, let's figure out what the addition problem is for the one on the top left. So, I'm going to go ahead and I'm going to grab blue for right now. We're going to use blue. if I remember using a number line, I always start at my home base. So here is where I started my arrow. And it looks like I'm going to the right 3 units. So the first number in my expression is going to be positive 3. Then it looks like at 3, I turn around and I go down. Let's count. 1, 2, 3, 4, 5, 6. I go down 7. So this is going to look like this. 3 plus negative 7. Now let's go ahead and represent this in chips. Now let's think about this. Surely after I create my 0 pairs for this, I should have negative 4 chips left over. Let's see if that's correct. All right, I'm going to go grab my colors. I have a positive 3 to work with. So I have 1, 2, 3 chips. There they are. And then I'm going to go grab my red to make my negative chips. I have 7 negative chips. There they are. All right, I'm going to go ahead and draw my 0 pairs. So I'm going to circle them. There's a positive and negative 0 pair, positive and negative 0 pair, and another positive negative 0 pair. What am I left over with? It looks like negative 4. Well, negative 4 is what I'm left over with, right? Well, isn't that the same number as where we landed on our number line? These two numbers are identical because it's the exact same problem, just represented using a number line and represented using chips. All right, let's try another one of those. Okay, this time I'm starting at my home base 0. But this time I'm going down negative 5 first. So negative 5 is my first number. Then I'm going to turn around and let's see how many I'm going to go up. It looks like 5, 6, 7. This area right here, that's 7 units. So I'm going to add positive 7 because I'm moving in the positive direction. All right. So there's my expression. Now, I know that my answer is going to be where I land, right? I know it's going to be 2. So let's see if I end up with positive 2 chips at the end. All right, I'm going to go ahead and I'm going to grab my negative first. I'm going to move this little guy over here. There we go. And I'm going to do negative 5 chips. 1, 2, 3, 4, and I'm going to put 1 over here. I'm going to go grab my yellow and I'm going to do my positive 7 chips. I'm going to put this guy over here. There we go. You'll notice why I put him over there in a moment. All right, I'm going to go make my 0 pairs now. All right, here's one 0 pair. Here's another 0 pair. Look at all these 0 pairs I'm creating. Those are all creating 0, so they're all basically eliminating. What am I left with? 2, positive 2. Well, fortunately, that is what we ended up with as our answer, not only in our expression, but also on our number line. So hopefully you're seeing the connection between the number line and using chips when working with integers. Okay, for this problem, we actually want to model a situation. The situation says Johnny owes his brother $2. He earns $5 for his chores. And after Johnny pays his brother, how much money does he have? So the first thing to know here is that Johnny owes his brother $2. When we think about the word owe, when you owe somebody money, that means that you're in debt. And that word is spelled like this. Debt. That means you owe someone money and you need to pay them back. So Johnny owes his brother $2. So we like to say this as if he's negative $2. But then he earns $5 for his chores. He earns. When you earn money, you make money. You have positive money put into your bank account. So in this case, we're going to be adding $5. It says, after Johnny pays his brother, how much does he have? Okay, well, let's look here. He owes his brother $2 and he has $5. So let's see here. Let's use chips first and then we'll use our number line. So I am going to use my negative. I have negative 2 chips. There they are. And then I have positive 5 chips as well. There they are. So let's go ahead and create some 0 pairs. I have 1 0 pair. I have 2 0 pair. Those just go away. And what am I left with? 1, 2, 3. Positive 3. So if this is equal to positive 3, that means that Johnny has $3 left after he pays back his brother. Now let's go ahead and just represent it on a number line so we can see the connection between the chips and the number line. All right, I'm always going to start at my home base 0. And in my expression, I'm going to go down to -2. Then I'm going to go ahead and I'm going to turn around, right? Because both of my signs of -2 and 5, they're different. So there's going to be a turnaround. And I'm going to add 5. When I add 5, you can see that it ends at 3. So again, 3 is going to be my answer, and I have 3 chips left, and it all ends up being a reasonable answer for our situation. If you were to get an answer like 27, well, that doesn't really make sense, because if you owe someone something and you don't really make that much more than what you owe, you're not going to have a significant amount of money left in your bank. Okay, and that is the end of this lesson.